Well, Paul here, and today on the bench I have this R&M fan, Robbins and Myers, and the customer sent it in. This is part of a Pedestal fan. Has a few complaints, basically the biggest one being that the cage is busted. Here, these have come off. This is bent back and hitting the blade. This one's off. So those two are off, and this one's off, and this is off here. So anyway, I'm going to take that off before I can power it up. But I also see some other issues too that need to be dealt with. One is it got hot, so we need to check the motor out. Actually, it got pretty hot. Someone had replaced the cable with this black wire, and it's grooved, so for neutral, so it's got some age to it. And this was what was on it. I cut it off, stripped the ends, and here's the wire. And when I stripped them, they look like that, and you can see how black that is. Well, of course, that's cloth that's wrapped around the wire, but when you unwrap the wire, you see the wire is not gray. Inside the middle, it's okay, but it got hot. Electricity runs around the outside of the wire, right? It's called the skin effect. And so the insides, they're copper, they're okay, but the outsides got hot. Now, that could be they got hot and some of this black, I don't even know what that is, some kind of string that was wrapped around the wire. You can see it there on that one. And it could be that got black on it, but it obviously got hot because it's not coming off on my finger and I just unwrapped it. It's actually the wire itself got hot. So that means current draw. And for this line cord to turn black, the motor has gotten hot. So I'll figure that one out, but I wanted to show you that. That's something to look for when you see a wire that's discolored. It's an indication that the stator might have got overheated. So hopefully not. Hopefully it's in good shape. Let's see what we can see here. Okay, it's rated at 0.75 amps, so that tells you right there what the current draw should be. You can see that there. And it's a 60 cycle, of course, or 60 hertz. And what else? Let's see. What does that say? I think it says 110, 120 volts. I'm about blind at distances, so let me see if we can see what that says. And I'm trying to hold the fan and camera and magnifying glass and everything at once. 110. It looks like 110 or 125 volts. Anyway, actually 100 to 125 volts, and it's it says XM or XN, but it's a nice big fan. It's a large unit. You can kind of get an idea from the soda can here. You can see how big it is. It's huge. So I'm going to go ahead and take the guard off, take the blade off. First thing I'm going to do is check the resistance on this line cord, make sure the switch is working. It's got a two-way switch here for the speed, or three-way, off, high, and low. And it's loose, so it needs to be tightened up. Hopefully it's working. So I'm going to check that next. I'll get the camera set up and then we can do this overhead where you guys can kind of see it, sort of overhead. Okay, well, let me get it set up and we'll continue. Okay, that's about as best I can do on getting the shot in the camera here. We'll go ahead and check this resistance first and see what we got on the motor itself, on the switch in the motor. So I think you can see that okay. I'm just going to connect it to the AC line cord here. I have to get that cloth stuff out of the way and kind of get the copper where it's shiny. Okay, let's get this one out of the way. Just reading the resistance in my hand right now. So I get the cloth out of the way, spread the wires out, kind of get them shiny. Okay. About as good as I'm going to get it. Okay. Just want to have a halfway decent connection on these alligator clip wires that I put on my unit here. Okay, one off. That's low. And you can see there's nothing going on there. And that's high. So we either have a bad wire here, a bad head wire here going to the motor, or we have a broken head wire up in the motor, or the stator is shot, or the switch is bad, right? We got to rule out all these steps. So we'll sort of work our way up. But the first thing we're going to do, I'll shut this off. First thing we're going to do is, I'm going to reroute this around the back there, is take this rod off because it's busted and we can't even turn it on with that there. So let's see, how do I get to those screws? Maybe I can get in there. You can't just weld aluminum, it has to be TIG weld. Actually there's a chance that it's non-aluminum, but it feels so lightweight. I'm seeing some rust here, so maybe it's non-aluminum. Anyway, whatever it is, I'm going to have it fixed. So we got that much off. Now, take these off. Somebody has had this off before. These are brand new washers. They're not the right ones for this, but it doesn't matter, right? Okay, now we want to see about getting the blade off. Okay, so we got the motor out, the blade off, and the guard. And that's off a little bit. It turns free, that's a good sign. It's actually turning really well, which is nice. You know? There's no real friction on the motor armature. That's a good thing. Maybe this wire was hot before it was added on here, who knows. But we need to get into the switch section here. So, since I've been using this gigantic screwdriver to take the blade off, I might as well use it to take the screws out. Okay, and there's the switch with the wires, and I'm just going to cut this wire here out of here because we won't be using that wire. And he's probably going to have to tape a new one on there. Maybe I'm going to suggest to the owner that he replace the entire wire. This goes down to the stand. So if I put a pigtail down here that's the same length, then he can splice into it with a new cord coming out. So I think I'm going to do that because this needs service here, right? It's all taped up and all kinds of stuff. So we'll just cut this wire out, but I'll leave a little bit of length on it for right now. I'll pull that out. Now we got room to work. Twist this. And those were twisted together, and that head wire is about losing its connection. So let's take the tape off and see what we got underneath. Yucky, sticky, gooey, tapey. Tapey, nasty, tapey. Sticky, gooey, melty, tapey. Okay. And okay, I'm going to go ahead and we got a red and a black wire going to the motor. There's another wire here, okay, that goes directly to the power line. That makes sense, because this basically goes from, this one goes directly to the AC line to the motor through the head wire. This one connects to the input side of the switch, and so you have off, high, low as you're turning the switch. Actually, I'm sorry, this one goes, yeah, high, low. So this is off here, and that's high, this one's high, and that's low. Okay, so off is on this side, my bad, but looking at it upside down. Anyway, yeah, that's off. So this they give you this 3-prong looking thing with a point, sort of like an arrow, right, with feathers in the back, and that's your indicator. So that's off because it's not pointing to anything. That's high, and this indicator should be touching this plate. And if it's not, then, and I don't think it is, and probably why they taped it. I think they taped it to cover the wire. If it's not touching, then you have no connection, right? So the fan won't run. Same thing here, although that one seems to be touching. Okay, let's start by tightening this guy up. I'm working on the camera? Yeah, okay. I have a habit of making videos and then you're not seeing anything I'm doing and I'm just over there doing it. Right, that stays, that's part of the switch, so it doesn't flop around or anything. We just want to tighten this nut here. And to do that, I have just the right kind of tool. Nice biggie boy, right? You get in there and grab that thing and not hurt anything else. Okay, so now that's nice and tight. We'll put the switch back on, leave it in the off position. It's a star shape, so it'll go on different ways. The new switches are not that way. This new switches, if this switch is bad and cannot be repaired and we have to put a new switch on, then this plate might as well go bye-bye because it's not going to line up with the new switch, and the new switch is not going to be one you can put at any angle you want. It'll only go in one way. It's just a square hole. And I will not get on my soapbox talking about the fact that this junk is made in China today. If you don't know that, you wouldn't be watching this video and you wouldn't be working on these antique things. Okay, so yeah, this one should be connecting to here, and that's the other way that works. See, it joins these two together, right? And when I turn it here, this one should be touching this, and it's not, and that one would be touching that. So that's how that switch works. So right there, it should be touching both of them. So what we're going to do for right now, because we're more concerned with is there a problem with the fan, we're going to take this wire out. This is old bulldog tape, which tells me that they changed this cord back in probably the 50s, which is a good sign, because that means that black junk that I've seen on the wire is probably from much age, because that would be a very old wire to have bulldog tape on it. Bulldog was a brand of tape that was out before vinyl, before plastic. It's actually cloth, and it's got sticky stuff on it just like regular electrical tape. And that was called, the brand that came out that was the most popular was Bulldog electrical tape. And so it got the name Bulldog over time because it's cloth based. So there's your history lesson for today. Now I need to kind of clean my hands a little bit from that gummy Bulldog tape. It's sort of tar based, so it's really sticky and gooey. Okay, but we need to know, is the stator okay? So what we're going to do is skip the switch. We know the switch has got issues and needs to be fixed, but we're going to skip it. So we're going to go right from the main power line that goes to the motor. We'll put the ground one on that one, it don't really matter. And we're going to try the other two coils. And one of these is the low coil in the motor, and the other one is the high coil in the motor. So we need continuity on both. And we have no continuity on that one. Let's try this one. We have no continuity there. So now we know that even though the switch is bad, we got a problem in the motor. Again, it could be this head wire, right? It's all frayed and yucky. If one piece of the wire let go, then no, we wouldn't get a signal. Let's try across these two. Okay, we got a signal across those two. So, and the switch is not touching them. But to rule out the fact that it could be the switch, I'm going to go ahead and take the red wire off. Okay, now we're going to check that again. So we're checking across the black wire and the red wire here. Okay, and we got continuity. So we have one coil that is connected. We have another coil, or it could be going to a capacitor. If it's going through a capacitor, we would have that. But I don't think it's going through a capacitor. Most likely either this wire is broken, or it came loose, or that part of the stator is shot. We won't know until we get to it. Now, there's no capacitance, there's no nothing there. Okay, so the next thing is to trace this wire. So what I'm going to do is, the red is low and the black is high. So I'm going to put some, actually, and this wire looks sort of greenish. So I'm just going to document that, just so I don't have to think about it, or try to remember, or worry about it. We've got an AC line coming in. Can you see my ugly, okay, it's my ugly drawing. We got an AC line coming in, okay? One end goes directly to the stator, okay? We got another wire that's coming in that goes down to the switch, connects to the input of the switch. The switch has an off, let's get it the way it is, off, high, and low, okay? So between the high and the low, we have another coil in here somehow, and we've got a reading between these two, so we don't have no break in this wire, and this wire here is connected up there too. Now the question is, was this connected here and burnt somewhere in this coil, excuse my ugly drawing, or is the wire here that goes up broken off and this is still connected? We need to find that out, because this coil is not working. This coil is. This coil is most likely just a coil, and this is probably connected here or in the center or on that side, and that gives it the power. So like when it's on low, it would go, this would probably connect somewhere in the middle. When it's on low, you know, you'd have more resistance. When it's on high, it'd be almost a direct connection. So that might connect actually right here. Right here on the high side. This may actually connect here. And so when you're on high, you're right across just this coil. When you're on low, you'd be on this side going through this coil and then through this coil. And that's more resistance, so the fan would run low. Okay, so that's what we're looking at when we're looking at this switch. Okay, so the high is black. No, I take that back. Yeah, the high is black. Okay, so this is a black wire. This is a red wire. And this one appears, and we'll put a connection here, this one appears to be either yellow or green. It's one or the other, it doesn't matter. The point is we know it's not red or black. Okay, so now we don't have to worry about disconnecting wires. We've got a drawing, we know exactly what's going on. So now we're going to take the switch completely off. We don't need the switch no more. It has to be serviced, but that's a different issue. Set it out of the way. Now we got to go and get to the other end of this head wire and test it. While I got that off, one more time, we'll check these three. So we'll go from the greenish yellow to the red, nothing, to the black, nothing, and across the red and the black. Oh, is it 12 ohms? 12.3 ohms. Okay, we don't need this right yet. Put him aside, give it some room. Now we have to take the motor apart because we got to trace this wire. I'm just going to leave it connected there and take it apart here. It's a nice old motor. It's well built. I mean, it's not cast iron, but it sure is close to cast iron. It's cast aluminum, actually. See here where the paint's gone? It's aluminum. And we're going to hope that that third wire is disconnected. love it when a plane comes together. Okay, there's the back of the unit. And here's the wires. And there's the oscillator. It's totally disconnected. I don't know where the screw went. But the screw's gone. And the oil all leaked out. Now the screw might be in the motor. Not in the housing. Well, if it's in there, it's wedged in there. Okay, but we ain't gonna worry about that one yet. We're gonna worry about this wire. And it comes in right here. So this should be the bundle coming through the stator here. Probably gonna have to pull this stator out to get, because these look like, unless that's red, black, and brown, that's a possibility. Let me get a needle, a pin of some kind, and we'll see what we can find out. Then find one. I think I had it. It's reading resistance in my body here. Try again. I seen a K for a second. Still megohms. The reason it's moving around is when I push, I'm putting more pressure on my hand on the. There we go. Okay, so that is the red. Now we'll try the black. Same approach. Hopefully not as difficult. Okay, we got it. See the black? Alright, now this brownish, reddish, orangish looking wire. What we're hoping is we don't get a connection here. Because if we do, it's not a good sign that the state is good. Okay, I'm not seeming to get a connection in there. No. Okay, we may be in luck. It could be this wire's bad. So, we have to take the stator out. Okay. Let's look at the other side a second. Okay. Got a tool that fits that. Looks too small. No, that ain't. Okay, there's the housing. It's interesting. And we see we have a broken belt washer in there. Not a big deal, I would place them anyway. Well, I'll get it out of there later. There it is. And the other piece is probably still on the armature shaft. But this brown stuff, that's interesting. It's like brown paint. You know? Okay. That's nastiness. Take the armature out. No, here's the washers. And no, the other half of that one's gone. I'm going to leave that one on there. Those on there so that I know how many go on one side. I know there's another one that goes there. This armature's not wanting to come out. And why not? Take that off. Get that out of here. Why are you not wanting to come out of there? Yeah, I see why. Dirty. Some oil in there. Why are you not coming out? Don't be stubborn. Actually, it's the stator we need out more so than the armature, but if the stator comes out with the armature, I guess that don't really matter, does it? Let's see if we can get the armature out though, and the stator without too big of an issue. The way this is made, it seems pretty nice. You don't want to tap too hard on anything like I was doing there. You don't want to tap hard on stuff like that because this is cast metal and it will break. And I've been putting the nuts and washers in separate piles so that I can put them back where they go. So that's a good habit to have. Normally I would just put them right back on there, but if I have to be tapping and stuff, I don't want to take the risk of bending the shaft. Once I get them off, I can put them right back on where they go loosely so that I know where they go and I don't lose them. Doing this is no guarantee that I'm going to get the stator out without getting the rotor out first. Motors are fun. They are cool though. Shut that off so my battery don't go berserko. Okay. Let's see. Now, these pins through the stator housing, the stator does not appear to be touching these. Oh, I see, they got a piece of insulation. Yeah, they wrapped like string or insulation, probably a piece of insulated wire in between the stator and these shafts so that the stator could self-adjust while it's running. But we're going to be very gentle and just try to tap it loose. And it may be that the bolts come out and not the stator. It looks like it's moving. The bolts are coming out. This one's almost out. Oh, yep, the stator's moving. But the bolts are also coming out. Alrighty. The stator came out some, but not as much as I would have hoped. Make sure we got plenty of clearance on everything. That's clear it there. No problem there. Yeah, there's like little metal clips. They're either clips or they're just insulated wire. Boy, this stator did get hot. You see here? Not too bad, but it got hot. I'm hoping that it's just that wire. I think it is just that wire. And now that I got a little clearance on there, maybe I can just shove that pin down in there. I'm going to try a different way. Let's put this back on the black wire, or the greenish color wire rather, and take this needle, put this back on ohms, back there, and try to come in. See, I can come in from the end of the insulation here now, and hope that I can touch the solder joint. Yeah, I'm all the way in, and I'm wiggling around, and I'm getting nothing. And let's try one of the others and see if that logic even works. This would be the red. That crackling noise is the bubble wrap. Alright, let's try the red and see. The red is in a bit awkward spot there, but I have to turn it around. Yeah, see? So I can touch the solder joint. You see the meter running all over the place when I hit it. But I'm not getting anything on this black wire. Let's try, this other wire. Let's try this one. And of course I should get something there. David, no, that's me. There it is, K. I actually hit it good. I'll go back to the red one, see if I can get a steady signal on that. Yep, See right there, K, it's in the 1,000 ohm range instead of the 12 ohms. Okay, but this one here, not that one, this one. This one here is not giving me a connection at all. Even when I get it in there and wiggle it around, I get nothing. That's a good sign. That's a good sign. It's a good sign that it's probably this wire and not the coil. If I got a connection, then the coil would be bad. But I'm not getting a connection. So we definitely got to get the stator out and run a new head wire. So what I'm going to do is I'm going to work on getting the stator out. Once I get it out, I'll continue the video. I'm not going to be prying and banging and make you wait for all of that. It's already getting long. I'll be back. Okay, I got the stator out, and it's a good thing I did. It's kind of nasty, right? It needed to be clean. Look at the inside of this housing. Look at that. See? Okay, so here's the stator. I went ahead and clipped it. Oh, it has these little things here. This is what I was seeing through the side. They hold it in place. Yeah. So they sit like, I guess they sit, well, this one's still in, so they sit in between there. That one just popped out, but I'll pop it back in there. It actually sits inside. There it is. Goes like that, and then that keeps the stator snug centered. You know, most of the cast iron ones before this, these here would have been out further and actually rubbed on the side of the stator to hold it directly in place. But this one allows a little bit of expansion. You see how they can move a little? See? So that kind of keeps the motor centered, and at the same time allows a little wiggle room under excessive load so that the stator is less likely to get hot or rub against the armature. All right, you see how the head wire goes in here, comes around to this side. Now, it looked like it was damaged here. I cut it off to get it out of the case. Of course, I'm going to put a new one. It looks like it was damaged here, and I would imagine, you know, it feels like it bends there. You know, it's stiff everywhere, right? It's ancient, but it bends there. So if anything, the wire is broken there. But since I had to take the stator out anyway, it makes more sense to go ahead and put a whole new wire in here. This head wire is short and stiff, and hear that? I don't know if you can hear that. Hear that? I don't know, you probably can't hear it, but it's like cracking when I bend it. It's just crunching around, and that's an indication that the wire is short. So to get the wire through, it's pushed through the stator here. You see it moving there? So we're going to disconnect it on this side and pull it out, push a new one through and connect it up. They got more bulldog tape here. That they used the bulldog tape as a means to keep the wire from being yanked through the hole in the back of the motor, which we will put a bush in and we'll put a wire tie. Okay, so the string is just holding everything in place. It's not critical, it's just convenient. Here they used some paper tape and you see it's not even holding. It's like an insulator basically. But what we want to do is get this wire out, so I have to take the string off. I have no choice. And I can either restring it, I probably will, or it really don't need it. You know, we could put wire ties here, 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 and here. Actually, these don't even have strings on them. So let's take a look at that for a second. Okay, yeah, this has a string going around it here, but it's really not tied over. See how it's tied over here, here, and here? These two are obviously to hold the wire down, this wire. But here it's even tied to keep the coil together. And so, and here it was, and it looks like the string broke. Yeah, it did, see? So, that's all that does. And see, the string's deteriorated. So what we'll do is put wire ties in there. They'll last a lot longer than string. The only way a wire tie won't last longer than a string is if a wire tie gets hot. It'll melt. But at that point, the fan is so hot that it isn't going to matter. The damage is already being done, and it has nothing to do with the wire ties. It has to do with the fact that the fan's running too hot and using too much current. We don't want that. So you see how easy that cuts. It's just all messed up there. Okay, let's just take it all out of there. I mean, I could put new string. I guess it would last, this string probably lasted 80 years, 60, 80 years. I guess a new one will last that long too. It's just, I don't like to use anything new that, you don't have to use new, because new stuff is not good. Not like the old stuff. So that's got paper on that one. Paper. See how paper deteriorates with age? Look at that. That's why when you're working on radios and tube appliances, you want to change paper wax capacitors, because they're deteriorated. The paper is deteriorated between the plates. That's why artists now use acid-free paper. They didn't know anything about it back then, right? We had some heat here. Something got hot here. So that's just paper down in between these panels here. These panels every so far, and that insulates the coil. But you see this heat, this black here? It got really hot in here. See how loose the coil is? Of course, I did take the string off, but you get the idea. See that? And that's what I was afraid of, that it would have burnt through in a place like this, and it may have burnt through there. I don't know until I find out what's going on up here. You notice how we started at the extension cord, we worked up to the switch, and we worked up to the head wire, and now we're going to work up to the coil itself. I got to be careful here. I don't want to cut the coil. All right. Okay. So now we can push that through, but we don't have much slack, so I'm going to cut these without cutting that wire. Take that one off. Put this back here, turn it back on ohms. And there. Okay, can you see the meter? Yeah, I don't think you got glare there. Okay, and you see if I touch them, they go down to 0, 1.2. So now we're going to try this black wire and this green wire. And see, we have a connection here, 17 ohms. Remember, we had like 12 ohms between, I think I'm on the right one. Now, I may be wrong because the colors are gone here. No, I'm not. That's probably 12. Yeah, see? There's our 12, and we have a new one of 17. And this is the one that wasn't connected. So it's looking good. It's looking good. Let's go ahead and get this out of the way. Now, what I need to do is document the colors. Okay, that's the yellow, that's the red. So this one is the red, this one's black, and this one's that yellow color. And let's check the resistance across all of these just to get an idea. I think this one was the 17. Okay, 17.5, and here we have 31.8. Okay, I'm going to write those numbers down on our little paper here. First, I'm going to draw the stator the way I got it here. So we have a wire coming out this way, we have a wire coming out that way, and we have a wire coming down. This one is the red, and this one is the yellow-green. I'm going to call it yellow. And this one is the black. Okay, black. So we got that R to B is 12.5 ohms. That's the one we've had all the time. Now we got R to a Y, and we got B to a Y. And right now we're on red, so the red to the Y is 30.7, give or take. And this one, I believe, was 17.5. 17.5. Okay, so now we got our wiring, right? Now the new wire that we're going to put in has black, white, and green. So what we're going to do is we're going to make the black equal the black. Okay, so wherever we have black, it's going to be black still. The white, we're going to make it equal the red. So wherever we have red, we're going to use the white wire to connect it up. And the green is going to equal the yellow. Okay, so wherever we have yellow, we'll connect the green wire. Okay, so that's our wiring diagram. So now that I got that, and we know what these are, even if I mix these up, I can separate them, take resistances, and get right back to that. So I don't need them laying this way. If I turn it over and they move, Doesn't matter because I can figure it out again, but I don't want to turn it over and make it move. I'm just saying if it does. So what I'm going to do is cut out the old head wire, but I'm going to leave some of the wire and make sure that all you got when you do this is just the head wire. So cut that one. So now that one's free. Now we're going to cut this one as close to it as we can get without cutting the copper wire. I'm going to desolder it anyway, but right now I just want to get this out and a new one in. So I want to leave it on there. Okay, that's that one. And now the black one. Now you see these two wires come here and connect together. There's actually two copper wires wrapped around the black one because it's two coils, and we talked about how they connect together internally in the motor. So what you do to undo it is untwist it a little bit. That separates the coppers out of your way, and then you can cut the wire. And that's the one, the black connects to the two wires, two sides of the coil. Okay, and this will come right out. Now let me get a head wire in there, and I'll show you the soldering procedure. But let me get a wire set up and ready to go.